strength was the same. Okay. Good morning, all of you.
Good morning, ma'am.
Good morning, ma'am.
Good morning, beta. Here.
Good morning, ma'am.
Good morning, beta. Good morning. We start with uniform reflection and non-uniform reflection. We are giving different name as the uniform reflection as specular reflection and non-uniform as diffuse reflection. Understood, beta? So now we are giving it a different name. Please begin. The same thing, but with a different name. Yes, beta. Start. Start, beta. What happened? Boys, can you hear me? Hello.
Yes,
Yes, please start reading.
Yes, ma'am. Specular, specular reflection. Reflection of smooth surfaces such as mirrors or a calm body of water. Diffuse reflection. Reflection of rough surfaces such as clothing paper and the asphalt
Roadway.
roadway. Each individual ray obeys the
Yes.
laws of reflection.
Okay. Now the uniform reflection. You can see over here is always from the smooth surface. Can you see this? That's what we had observed earlier. This is specular reflection. What it is called as? Specular reflection from the smooth surface. See, this surface is even, a smooth surface. Maybe it's like a glass or a plain mirror, or it could be a surface of water. You got it? Now you can see the parallel rays coming. Can you see this parallel rays coming? And the parallel rays reflecting. Got it? Parallel rays reflecting. You understood better? So that's why you get a very clear reflection. Very clear picture you get in specular reflection. Show you how it looks like. See, can you see this? The reflection of the sun in water. Can you see the reflection of sun in water, better? This is specular
Yes,
reflection.
ma'am.
Now we come to diffuse reflection. Where does it happen? When the surface is, see, uneven. You got it? Surface is uneven. Hope you understood. We get a diffuse reflection. It is always on rough surfaces. Now let's see exactly what happens. What you see, it's all parallel lines. You agree, beta? The blue lines are all parallel lines. Agree or not? But when it is getting reflected, it is going in all the sides. See? All the directions. See, one is going here, the other is going here. Can you see this? So it's going anywhere. It's going in all the directions. And hence, we don't get a clear-cut picture or clear-cut image. Example, see how it looks like. Can you see this? Hello, you got the image? It's a diffused image. Hope you understood now the difference between specular reflection and the diffuse reflection better. Yes or no? See, this is it. You got the difference?
Yes, ma'am.
All of you understood what is the difference between a uniform and a diffuse reflection better? Yes?
Yes, ma'am. Yes, ma'am.
Now I'm going to teach you another phenomena of light, that is refraction. What is that better? Refraction. So now we are going to talk about what is the difference between reflection and refraction. Okay, please read better. Please read.
Reflection versus reflection.
Be a bit louder.
Light bouncing off a surface. Angle
Then light
light
bends because
bouncing
it
off
changes
surface.
speeds. The first point is light bouncing
Light
off a
bends
surface.
because
That is
it
reflection.
changes.
Exactly. And refraction is light bends. Here
Ma'am,
is light is bouncing and here light is bending.
ma'am,
Please.
ma'am, I am
Yes?
reading first reflection and then reflection.
Okay, do that. Do it, beta.
Light bends because it changes speeds as it changes mediums. Angle of incidence, angle of reflection is equal to angle of reflection.
Okay, fine. Thank you. Now, what we see in reflection, that light bounces off. See, this is the incident ray, got it? And then it bounces off. Agree? So this is incident ray and this is reflected ray.
Yes,
All of you
ma'am.
agree or not, beta?
Yes.
Hello? Okay, then we get a normal, isn't it? The central line is a normal.
Yes,
And this one is angle of incidence, that is angle I, and this is angle R. So what we know, angle I is equal to angle R. All of you agree? All of you agree? Hello?
yes,
Boys, can you hear
yes, ma'am.
me? Yes, you agree. Fine. Now this is reflection. So what we will see over here
Yes,
is a
ma'am.
refraction. That when there is
Yes,
a two
ma'am.
medium, for example, which is the medium that we are talking about? One is air. What is inside? Water. Do you follow me? Hello? Do you follow me? There are two medium. One is air, the other one is water. When I put a pencil or a straw inside the water, this looks okay. And suddenly it looks broken, bend. Can you see this? You can see the light bend as if it is broken. Have you ever observed this? Boys, can you hear me?
Yes,
Yes? Have you ever observed this phenomena, beta? Hello?
Yes,
yes,
ma'am.
Yes, you have observed this phenomenon. Fine. This is
yes,
called as
ma'am.
refraction. What it is called as? Refraction. This is a light phenomena. So reflection we know. I'm giving you a one more new thing that is called as refraction, where you see that when light enters from air to water, what happens? We can see a bend, the light bends, and the things look broken. That phenomenon is known as refraction. Okay, beta? Now we're going to talk about a new topic that is multiple reflections. Please continue.
Yes, ma'am.
Can I read?
Oh, yes, you can, beta. I'm glad that all of you want to read, so it makes me happy. Please do so.
Multiple reflection. To predict the path of incident rays, for this case we need to apply the laws of reflection again. However, at the same time, understand that when two mirrors are placed at an angle, the rays of light are reflected multiple times through them. For instance, when two mirrors are set parallel facing each other, they will create the illusion that the image of the object repeats forever.
So what you see, what you see is that you are getting so many times of image for one object. Now can you see over here? It's a perfume bottle. Can you see this? This is one. This is the object. You understood better? Hello. And you get so many images. See, you can get these images. These are all images. Even in the lift, you
Yes,
can see
ma'am.
so many images, isn't it? Hello? Hello?
Yes, ma'am.
Yes. Even in the lift, you can see so many images. You know, like you are standing, you are
Yes,
an object, but so many multiple reflections you get in the lift because it has got all parallel mirrors. They're facing each other. You got my point? So that is called as multiple reflections. What it is, better?
yes, ma'am.
Multiple reflections. Same thing you can get over here.
Multiple
This is an arrow.
reflection.
Yes. This
Lift
is an arrow.
reflection.
See, this is an object. This is an arrow you have drawn. The same arrow could be seen as 1, 2, 3. Understood? So many reflections you are getting. Any problem, beta?
Yes, ma'am.
No, ma'am.
No, ma'am.
I understood. Let's see
No,
exactly
ma'am.
what is happening in multiple reflections. Yes, read, beta. Read.
Multiple reflection. Reflection from the front and back surface give a double image.
Fine. Now see over here. This is a glass. When you paint it from behind, it becomes a mirror. You agree? Hello. Take a glass and on one side you paint it. Then that glass becomes a mirror. Do you agree with me?
Yes, ma'am.
All of you?
Yes.
Yes? Okay. See now what is happening. This is the incident ray. This much. This is the incident ray. Okay? Hello? It
Yes.
gets reflected. It
Yes,
gets
ma'am.
reflected. This much you agree? This is incident ray gets reflected. But
Yes,
Yes.
ma'am.
remember, from air, it is going to glass. So what will be this? See, there's a bend of this light. This is called as refraction. So what is happening over here? Refraction and reflection. Both phenomena is happening, beta. Do you understand? Do you understand?
Yes, ma'am.
So you can see over here, there's a bend of light. Can you see this over here? The light is not straight. From here, the light bends. Here, again the light bends. Are you understanding? It's a straight line. It's a straight line, but here it is bending. It is going away. Can you see this? It is not a straight line. Can you find that this is a straight line, but there is a bend? Can you see this? From here also it is a bend. From here also it is a bend. Agree?
Yes, ma'am.
And hence we get the multiple images. So many images we are getting. Got it? So that's why it is written as the ghost image. What is written, beta? Because image is only one. So many images are you getting, so it is a ghost image. So multiple images are also called as ghost image. Any problem?
Ghost image.
Any problem, beta?
No, ma'am.
When you go to a saloon for haircut, yes, the barber shows you a mirror like this. Does he do that?
Yes, ma'am.
Yes, exactly. Now, you can see the back of your head by using two mirrors. So what you are doing? You are having the multiple reflection. You can see the back of your head like this. See, isn't it? What is it? It is multiple reflection. Getting my point? This reflection is observed here. Understood or not? So you become the object and this becomes the image. Any problem?
No,
No,
ma'am.
Again, many examples of multiple reflections. See, this one, there's only one object, so many images you're getting. This is the object and these are all the images. Okay? Understood, beta?
Yes, ma'am.
Same thing over here. This is the object. How many images are you getting? One, two, three. Understood?
Yes, ma'am.
Multiple reflection. I'm giving all the examples of multiple reflections. See, again the same thing. Multiple reflection. So many images. You got only one object. This is the object and so many images. See, one, two, three, four, five, six, seven. 7 images you got, okay, of one object. So these are all again multiple reflections. Same thing you can observe over here. Yes, beta. This is the object, and you're getting, got it? Images. Any problem so far? I've tried to give you all types of examples of multiple images. Any problem, beta?
No, ma'am.
Same again. This is how it looks like. See how many images you're getting? Many number of images, isn't it? Hello.
Yes.
Yes.
In this case also you can see these are all you usually get in the hotels. Now we come to kaleidoscope, which is working on multiple reflection. You know what is kaleidoscope, beta?
No, ma'am.
No, you don't know. Okay. It's like a tube, and you look over here. Inside there will be pieces of what do you call this? Bangles. You put it inside, and when you keep on moving, you can see lots of images, patterns, varieties. It's nice to play with. I will be showing you what exactly is. Please read it.
Kaleidoscope, an illustration of multiple reflection. The kaleidoscope also uses multiple reflection through mirrors to form beautiful pattern.
So you get this sort of patterns with the help of kaleidoscope. When you keep on moving, see these sort of patterns you get. Okay. Let's see what exactly it is. Please read it. Anyone else wants to read? Moinuddin?
Yes,
Does
ma'am.
anyone wants to read, beta?
Means he is reading only.
Exactly. That is what I'm saying. That if anyone wants to read, they can, if they wish. Okay, then both of you can take a chance by chance and let's finish this chapter, beta. You
Okay.
also can read, no problem.
Introduction. A kaleidoscope is a circle of mirrors containing loose colored objects such as beads or pebbles and bits of glass. As the viewer looks into one end, light entering the other and creates a colorful pattern. Due to the reflection of the mirrors, the, the word kaleidoscope is derived
Derived.
derived from the ancient Greek words beauty, shape, and tool for examination, hence observe of beautiful forms.
Okay, thank you. What is kaleidoscope? This is a circle of mirrors. Okay, and inside you will have colored objects, loose colored objects. For example, it could be beads, or it could be pebbles, or it could be pieces of glass. When you are looking into the kaleidoscope from one end, so light is coming from the other end. It shows a very beautiful pattern, the colorful pattern, because the mirrors are reflecting the light, and you can see the patterns. This word is obtained from Greek word, and it means that it gives the beauty, the shape, and you're like you're playing with it. So you can be called as an observer of beautiful patterns or beautiful images or beautiful forms. You understand? So with kaleidoscope, you can see beautiful patterns, varieties. Is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
Let's see how it works. Please.
How it works. Kaleidoscope operate on the principle of multiple reflection, where several mirrors are attached together. Typically, there are three rectangular lengthwise mirrors. Setting the mirror at 45 degree creates 8 duplicate images of the object, 6 at 60 degree, 4 at 90 degree.
Thank you. How do we make kaleidoscopes? How does it work actually? We talked about multiple reflection. I think you're all aware of multiple reflection, how it is produced and what we get out of it. So what are we doing? We are putting several mirrors. They are attached together. But in kaleidoscopes, we take only three mirrors. How many mirrors, Vita?
Three
Hello?
mirrors.
Three mirrors.
Three.
Three rectangular mirrors. And generally we keep it at 45 degree. So this is how we put, like a triangle. This is one mirror, this is second mirror, and this is third mirror. You understood? Hello? It's like a
Yes, ma'am.
triangle. It's like a triangle. And then we cover it with a roll of paper, beautify it, and observe it from one end and see the patterns. Yes, begin. How does it work?
How its work. As the tube is rotated, the tumbling of the colored objects presents the viewer with
Reading.
varying colors and patterns. Any arbitrary pattern of objects shows up as a beautiful symmetrical pattern created by the reflections in the mirrors. A two-mirror model yields a pattern or patterns isolated against a solid black background, while a three-mirror closed triangle model yields a pattern that fills the entire field.
So there are kaleidoscopes where you can use two mirror, where you can use three mirror. Generally, we are using three mirrors. You understand? Because we get beautiful patterns. In two mirrors, you don't get much of a pattern because there is one background, a black background. Whereas in case of three mirrors, it is totally brightly lit up because from one end, the light is entering. You understand? Yes? So what you do, you take the tube, put this glass inside the tube, and then you keep on rotating the tube. When you rotate the tube, the glass pieces or the beads they start tumbling inside at one end of the kaleidoscope, and it gives a beautiful view of different colors and patterns. You understand? So why this pattern is created, and these patterns are always symmetrical. Remember that these patterns are always symmetrical. You know what is symmetrical image? The left equals to right. That is called symmetrical image. You understand? So you get a beautiful patterns which is created by which effect it is called as reflection. So reflection of the mirrors is creating beautiful patterns. What type of reflection is this? Multiple reflection. Any problem with that?
No, ma'am.
Okay. See now one by one we'll see. Look at this pattern. This is kaleidoscope. This is how you observe. Okay? See, all are same, symmetrical. Don't you find this symmetrical better? Hello? The left is
Yes,
equal to
ma'am.
right. And I can cut it into, see, if I cut it like this, if I cut it like this, it will become four equal pieces, isn't it? One,
Yes, ma'am.
two, three, four. So patterns are very symmetrical. Next one is this. How beautiful it is, isn't it? These are the
Yes,
patterns that you get better. Look over here. See this one. How beautiful it is. These are all made up of glass pieces, remember. Different type of colored glasses they have used and they got all this wonderful patterns. Can you see this better? This is called a
yes,
kaleidoscope. This is the most beautiful of all. See this one. And this is the complete pattern. They've taken, assembled. This is how it looks like. They've assembled one pattern. Okay. You don't get everything together, but separately you get. Now we will come to what exactly is sunlight and what sunlight is made up of. Please continue.
Sunlight
I'm gonna read.
and its color. The seven colors are violet, indigo, blue, green, yellow, orange, and red. All this spectrum of colors we can perform this simple activity.
Okay. Now, if I say what sunlight is made up of, what will be your answer, beta? Spectrum. What will you answer? Spectrum. If I say V, I, B, G, Y, O, R. What it is? Vibgyor. Can you say with me, beta?
Vibgyor.
Vibgyor. What is V? Violet. Say
Violet.
violet. I, indigo.
Indigo.
B,
Blue,
blue.
Blue.
G,
green,
green.
Green.
Y,
yellow,
yellow.
Yellow.
O,
orange,
orange. R,
Red.
red.
you got all the colors? Vibgyor. What it is?
Vibgyor.
Vibgyor. This is how you
Vibgyor.
have
Vibgyor.
to remember. Yes, this is how you have to remember. And then you can remember all the colors of spectrum. Is it clear? So
Yes, ma'am.
sunrise. So sun rays, it is made up of seven colors. Is this clear? And these colors are known as spectrum. What are they known as? Spectrum.
Spectrum.
So spectrum is made up of seven colors, which makes a sun ray. Any problem?
No, ma'am.
Now see, do an activity. The sunlight is falling on a glass. Yes, this is a glass. It's falling on a
Yes,
glass.
ma'am.
It gets refracted or dispersed as spectrum. You can see this
Uh,
Vibgyor on a piece of paper. Yes, got? Did you understand?
Yes, ma'am.
So we see light dispersion and spectrum. The white ray got dispersed into seven colors. You understood?
Yes, ma'am.
Start. Please start reading.
Light, light dispersion and spectrum. How many colors are there in light? How possible is it to split white light into different colors?
You understood? So if I ask you how many colors are there in light, what you will say? Vibgyor.
Seven.
Seven colors. What you will say?
Seven colors.
Vibgyor. So Vibgyor is
Vibgyor.
Vibgyor. That is seven colors. Any problem?
No, ma'am.
Did we split this white light into different colors? Yes, we did, isn't it? Is it easy to split? Yes, it is very easy to split colors. Here you can say it is a prism. Can you see this? This is a prism. Can you see this better? It's a prism. White light comes from here and does get split into these seven colors. Can you see this? This is called a spectrum. What it is called?
Spectrum.
Ma'am,
Do it.
I can observe it.
Yes, better. Yes. Have you done this?
Yes,
Have
ma'am.
you observed this activity? Okay. Even you get it on those CDs. Have you observed that? CD?
Yes, ma'am.
Yeah,
Yes,
yes,
you
ma'am.
can see
Yes,
this
ma'am.
rainbow colors on CD, remember? Even
Yes, ma'am.
sometimes you get this color in your bubbles. The soap bubbles you get.
Yeah. Yes,
So
ma'am.
many times you can get this color, rainbow color. Okay. Now this mechanism is called dispersion. What you will say, beta?
Dispersion.
Dispersion. What is happening? That white color is dispersing into seven colors. Hope you understood.
Yes, ma'am.
White color is dispersing into seven colors, that is called a spectrum. Any problem so far?
No, ma'am.
So now see what we are going to do. Pay attention so you don't have to revise it again, beta. This is what I want to play as much as possible. So in the lecture itself, you pay attention so you don't have to read it again. What do I say?
Yes, ma'am.
Okay? So just be a bit serious. So this much of time will be saved and then you can enjoy your life. You can play, you can do your hobby. Is it clear? I don't want you to keep on reading the whole day. I wish that you enjoy, you play, you do your hobbies. Is it clear? This is white light. And when it goes to the prism, it gets dispersed into how many colors? Vibgyor. You got it? So this is the Vibgyor, the spectrum. What it is called as? Spectrum. What it is called as, beta? Spectrum. Any problem?
No, ma'am.
No, ma'am.
No, ma'am. No, ma'am. No, ma'am.
Nothing.
Again, the spectrum of white. So this is the white light. You see this white light, beta? And this gets dispersion. This is the spectrum. Okay, beta? Hello.
Yes, ma'am.
Yes, ma'am.
Now see what exactly all this reflection is observed in human eye. What is human eye made up of? Please adjust your mic better. Some noise at the background. Yes, please read the human eye.
The human eye. The human eye, a sense organ. It helps in seeing different objects. The light reflected from different objects enter our eyes, and thus we can see things around us. It is an important organ, so understanding its structure is also very important.
Right. So what is human eye? It is a sense organ, right? We have got five sense organ. Say something, Baba.
Yes,
Yes. So human eye is one of the sense organ. Very delicate, very important organ because we can see different objects with the help of an eye. What is happening? How we see things? Because light gets reflected from the objects, and after reflection, that reflected ray enters our eyes, and we can see things, whatever is present around us. Very important organ, the eye. So we should understand the structure of the eye. Now, see over here. Look, main is now the outer is a white thing. Remember, it's a white thing which is giving a protective layer on the eye. Then you have cornea. What do you have, beta? Cornea. Got it? Inside the cornea, you have this red, not red, sorry, this brown or black color pupil. What it is called as? Center portion? Pupil. Behind the pupil, we have the lens. Can you see this? This is the lens. This is the lens. Behind the pupil is the lens. Any problem? Now we come to the arrangement of pupil because I think I taught you in seventh standard maybe that when you go out in the sun, yes, your eyes become small. Yes or no?
Yes,
Yes.
ma'am.
Yes? Okay. And when you go inside the dark, your pupil become big. Have you observed that? This is due to iris. It is due to iris. See, these are the muscles which is allowing the pupil to contract and to relax. Understood? Hello? Understood?
Yes, ma'am.
Yes, ma'am.
So, which is the important thing? This lens. Which is the important thing with a lens? So, light is traveling, is going in the lens, and then image is formed on retina. Here, the image is formed. This is the place the image is formed. Is it clear now?
Yes, ma'am.
Yes, ma'am.
Okay. So image is formed on retina. Where it is formed, beta? Retina. Image is
Retina.
formed on retina. You should always remember that. Now, why do we wear specs? Because sometime image is formed here or sometime image is formed here. So we use spectacles to correct our distance so that the image forms on the retina. This is how the image is formed. Any problem? So we are wearing the glasses for the correction of our eye. Any problems?
Yes, ma'am.
Understood?
Yes, ma'am.
Yes, please read.
Ma'am, lecture is over.
This is over, beta? Okay, thank you for reminding me.
Welcome.
So next session we will be starting with this much. Have you understood whatever we learned today? Is there any problem whatsoever? Boys, do you find any difficulty?
No, ma'am.
Okay, beta. Okay, thank you, thank you. And if you wish that I should change my ways of teaching, you can let me know. Okay? If you think it is okay, then we continue. If you want me to change, I will change. Whatever you say.
Okay,
Clear,
ma'am.
beta? Okay, beta. Have a good day and enjoy your life.
Thank you, ma'am. Bye.
Bye,
Have a good
ma'am.
day.
Bye, beta. Bye, beta.
Bye, ma'am.
Bye, beta. Bye, beta.